I had a big explanation for what, oh, it's not starting. Oh, it is. I had a big explanation, but you can kind of watch, and it's kind of a weird explanation, and I don't know how much I'm going to share it. So I took a lot of time to make this slide so I could move all these weird, show all my little people around. And once I showed it, it really wasn't helpful. But here you go anyways. So in math, there are very few rules, right? Like there's very few like, ooh, don't do that. Don't, you're not allowed to do that, right? But there is one thing you're not allowed to do. So imagine you have a pizza sitting in a room, right? And you bring in a friend and the friend and you say, look, dude, you can have that pizza. And I ask you, he's sitting right there, how many pieces does he get? Well, if he's the only one in the room, he's going to get 8 pieces, right? You're taking 8, you're dividing it by one person, yay. And if he says, well, I have a twin, can he come too? I could say, sure, you both can split the pizza, right? And that's totally fair. And I'd say, how many pieces does each guy get? Each guy gets 4 pieces. It's all good. And what if he said he was part of that weird Octomom lady? Remember her? And she had like 8 kids at once, and it was creepy and weird. And if you see, I mean, they're still a family. It's very strange. So he had 7 brothers and sisters, and you split the pizza up. Each one gets 8. All of those are fair. He could keep bringing in more family members as much as he wanted to, right? That's math. That's 8. That's 8 divided by whatever. So we can take the number 8 and we can divide it by anything, right? We can divide it by 1. We can divide it by 3. We could divide it by 8. We could divide it by 8,000 if you wanted to. If he had clones, 8,000 of them come in. Maybe they each just get a tiny bite of pizza, right? That's all fair game. But there's one thing we're not allowed to do in math. There's one thing we're not allowed to divide by because it kind of makes things explode. Does anyone know what the one rule that we can't do in math is? Yeah, for some reason, we can't divide by 0. It's not allowed. And let me tell you why. Because what you're saying is, you have a piece of pizza sitting on a desk, and you say, if no one comes in, how many pieces does each person get? And it's like, well, there's no one. And it's like, yes, how many pieces do they all get? And it's like, that doesn't even make any sense, right? So we're not allowed to divide by 0. And what I used to tell students is, think of it like dividing by a ghost, right? If there's no one in the room, the only people that are in the room are ghosts. And giving ghosts pizza is mean, right? Because they don't have hands that can grab the pizza. It's mean. It's like, hey, ghost, have a piece of pizza. What? You can't grab it and eat it? I'm just torturing you? Ha ha. That's a mean thing to do, right? We are not allowed to divide by ghosts or 0. So here's something to write down in your life. You can live this. In life, you can't divide by ghosts, and in math, you can't divide by 0. There you go. You're welcome. I have taught you something to live your life by. Yes. I'll give it to her in a second. I'm going to keep on rolling, and then I'll get it for you. Now, you're thinking, why does this matter? And here's where it gets a little weird. And it gets weird because it turns out we, at this point, let me get a new thing on here. I'm going to insert a blank page. We now have variables in our problems. So we are actually saying 5 over x. That's the problem we're doing. And x can be anything, right? X could be 100, or x could be 3, or x could be 25. But x, there's one thing x cannot be. What's the thing that x cannot be? It can't be 0. It can't be the ghost number. So that is called a new thing. That's called an excluded value. That's saying, hey, by the way, everything in the world works except for 0. Don't plug in 0, right? That is called an excluded value. And in other classes, what they say whenever we do algebra fractions, they will say, solve this problem or simplify or multiply or divide and include the excluded value. And they have to write the answer, whatever the answer is, and this. And you're thinking, oh, Mrs. Tarantino, why are you making a big deal out of this? I just write not 0 every time. except you don't. And here's where it gets a little dicey. So check out this problem right here. X over 5. I'm going to change it a little bit. Okay, so watch what happens here. If you say to me, Mrs. Tarantino, X can be anything but 0, I'm gonna actually test you on that. Watch what happens when I plug in 0 right there. What is 0 plus 3? 3. Does that, am I dividing then by a ghost number? No, I'm dividing by 3, right? That's not actually 0. But there is a magical number out there that would turn this whole thing into 0. What would I have to add to 3 to turn the whole bottom into 0 and be a bad thing at the end? 3 plus something would give me 0. Someone said it. -3. Exactly. So in this case, the bad number, the excluded value is not 0. 0 is fine. The bad number in this case is -3. So here's what they have to do in other classes is before they start a problem, they've got to see if there are hidden bad numbers, right? So here's the way I think about it, which is, so on this one, so let's take a look at this real quick. The bad number on this one is easy. It's just 0, right? X can't be 0. But the bad number on this one is not 0. It would be -5. You got it. You know what it's like? It's like when we would suck our answers out backwards, right? It's that same kind of thing. So here's what I tell my students to think about. Think about, now I'm mixing up my analogies. It's just getting weirder and weirder today. Imagine that, has anyone ever tripped in a gopher hole? Like when you've been running? Yeah, you can really break your ankle, like seriously, because gopher holes are deep and you're running and like kids break their ankles in gopher holes all the time. Like it actually happens. So imagine you have friends coming over to play in your backyard and you're going to tell them, well, let's go on my swing set, let's play on my trampoline, let's go swimming in my pool, but be careful over there in the back corner, don't step in the gopher hole, right? Be careful, there's a gopher hole over there. That's what we're doing tonight. We're going to be doing some problems, but before we start the problem, before we head to the backyard, we need to check out where the gopher holes are and we need to warn them. Then, once we've warned them, we do the problem just like normal, right? Now, a couple things to keep in mind. One, sometimes you have a bad gopher problem. So there might be more than one gopher hole. There might be 2 gopher holes, right? So it can't be -5 and it can't be +4, right? Sometimes there are more than one gopher hole. The second thing is, no one likes playing in the front yard. The front yard is boring. So I don't care what the hell is happening on top. Everything's fair game on the top. You can have 1,000,000 gopher holes in the top. Doesn't matter. You don't have to worry about those. You can only worry about the backyard. Only worry about the denominator. That's the only place we care. So what I'd like you to try is I would like us to do a few of these. So here we go. Some higher level classes ask you to list the excluded values before you simplify. I will ask you to do a few of these right now. And then on a quiz, I may have one problem where I say, hey, what's the excluded value? I need you to be aware of it, right? So for those of you who may be taking a placement test for DVC, you're not going to be like, what the hell is an excluded value? And for those of you going to pre-calc, when she says, oh, don't forget the excluded values, you're going to be like, oh, gopher hole. And you're going to know. So don't turn over your paper yet. Get a whiteboard pen. We're going to do 3 problems together. And then I'm going to have you try it on your, you're going to practice some. So let's do a few together. And then I'm going to have you practice some. So here we go. Let's see how we do. Try this one. I want you to give me the excluded value. Okay. So here's what. We don't do the simplifying first. What we do very first is we look at the denominator. I don't even care about the numerator. I don't care what's happening up there. I look at the denominator. Is there a number there that would make this whole problem on the bottom become 0? What's the number I have to avoid on this one? 0. I have to avoid 0. So we just say x can be any number in the world, just not 0. It's not 0, right? If it's got no plus and minus, it's super easy. It's just 0. Check out this one. 3x over 8. What is the excluded value on this one? This is a trick. Is there any x's in the denominator? No, you know what that means? I don't have any gophers, right? Maybe I do in the front yard. Who cares, right? Don't play in the front yard. But in the backyard, my backyard's good. I got a dog. The dog chases away the gophers. I'm cool. No excluded values. That happens sometimes, and that's okay, right? Okay, let's get a little trickier because you guys are badass. You can do this. So how about this one? 7x over x minus 6. What is my excluded value on this one? Someone said it? Is it 6? Yeah, it's 6. X can't be 6, right? Nice and easy. Okay, stepping up our game. You know how I do this. Always, always, always. Okay, how about this? Ooh. This one's going to be tricky. Oh, I'm going to change it a little bit. Hold on. Let me make it a little bit. I'm going to go a little easier. A little easier. I was going to go too hard. I want my excluded value. So here's my advice. Factor the bottom first, right? Factor it first because there's an excluded value hiding in there. He's hiding. So first factor it and then do your excluded value. Don't start canceling, but go ahead and walk around your backyard and see where your gopher holes are, right? Factor this first on the bottom, pull out your excluded value, then you do the rest of the problem.
So it's always going to
X is the thing that's our variable, so that's what we're going to be plugging into. Yes. Yes, or we're trying to factor it, right? So is there something that goes into 2 and 6? 2, right? So here's what I got, x minus 3. So now I'm looking at this guy. What could I plug in that would be bad to make this thing turn into 0? What would be the bad number here? 3. You got it. So x cannot be 3. You could have done it here, but it's a little more work, right? It's a little more effort to kind of go in your head, what times 2 minus 6, right? But if you factor it, it makes it super easy, right? You did it in your head. Yeah, and some people do. Last one, and then I'm going to have you practice some on your own. So here's the last one I want you to try. I want you to we're going to actually do this whole problem. X squared plus 8x plus 15. Okay, you got gopher holes on this problem. You got some serious gopher holes. You have more than one gopher hole, and they're hiding, right? They might be under a leaf or something like that, or behind a fence. So you're going to need to factor that bottom to find your gopher hole, right? So I can't figure out just by looking at that what would be some of my bad numbers. Right? I can't even do it. I don't want to plug in. I don't want to just like guess and check. That's a pain in the ass. So factor that baby. X factor it. Find your gopher holes. Figure out your bad numbers. So look for your excluded values. And I am finding the starter. Yes, that's what we're, and whenever we are doing the obstacles, because we're setting it equal to 0, right? That's what doing the obstacles. Yeah, it's like solving for 0, because really that's what solving is setting it equal to 0. So did you do this? Did you say, factors of 15 that give you 8, that's going to be 3 and 5. So I have x plus 3, x plus 5. And you're going to say, oh, wait a second. Before you go out and play, before you go have fun in my backyard, Stay away from two things. Stay away from -3, he's bad, and stay away from -5, he's bad as well. Now let me ask you this. If I said, now simplify it, how would you finish this problem? What would be the actual answer to this problem? That's just a warning. What's the actual simplified version of this problem? Andreas, what is it? Awesome. Because what he did is he canceled this and he canceled this. He knows you can't have nothing on top. So it's 1 over x plus 5. This is the answer. This is the excluded values. They're two different things. And like I said, you talk to your friends in Algebra 2 Trig, those Algebra 2 Trig teachers, because it's in the book, make them do that for every single problem. I want you to practice it, but we're not going to do it over and over again, as long as you understand it, okay? Do me a favor, turn your paper over. I'd like you to try the other side. There are 6 problems. Number 6 is hard. If you're a pre-calc kid, maybe give number 6 a try, but everyone else should be able to do number 1 through 5. Get the excluded values and then simplify. I want both. I want the warnings and the solution, right? So there you go. I like this. Yeah. Oh, hold on. Let me do this. That's